Welcome to SS2 Mathematics. This lesson covers advanced differentiation, extending the basic rules of differentiation introduced in SS1 to more complex functions using the product rule, quotient rule, and chain rule. These techniques are essential for WAEC further mathematics and for university-level calculus. From your SS1 studies, you know the power rule. The derivative of x to the power n is n times x to the power n minus 1. You also know that the derivative of a constant is 0, and that derivatives of sums and differences work term by term. In SS2, we extend differentiation to products of functions, quotients of functions, and compositions of functions. These require 3 new rules that allow us to differentiate much more complex expressions. When 2 functions are multiplied together, we cannot simply differentiate each part separately. The product rule states, if y equals u times v, where u and v are both functions of x, then dy over dx equals u times dv over dx plus v times du over dx. In words, differentiate the first, keep the second, then keep the first, differentiate the second, add the results. Example, differentiate y equals x squared times e to the power x. Let u equal x squared, so du over dx equals 2x. Let v equal e to the x, so dv over dx equals e to the x. Applying the product rule, dy over dx equals x squared times e to the x plus e to the x times 2x. Factorizing, dy over dx equals e to the x times x squared plus 2x equals e to the x times x plus 2. When one function is divided by another, we use the quotient rule. If y equals u divided by v, then dy over dx equals v times du over dx minus u times dv over dx divided by v squared. Memory aid, the quotient rule is often remembered as low d high minus high d low over low squared, where low is the denominator and high is the numerator. Example, differentiate y equals x squared divided by 2x plus 1. Let u equal x squared, du over dx equals 2x. Let v equal 2x plus 1, dv over dx equals 2. Quotient rule, dy over dx equals 2x plus 1 times 2x minus x squared times 2, divided by 2x plus 1 squared. Numerator, for x squared plus 2x minus 2x squared equals 2x squared plus 2x equals 2x, x plus 1. So dy over dx equals 2x, x plus 1, divided by 2x plus 1 squared. The chain rule applies when one function is composed with another, a function of a function. If y is a function of u, and u is a function of x, then dy over dx equals dy over du times du over dx. This is the chain rule. Multiply the derivative of the outer function by the derivative of the inner function. Example 1, differentiate y equals 3x squared plus 1 to the power 5. Let u equal 3x squared plus 1, so y equals u to the power 5. dy over du equals 5u to the power 4. Du over dx equals 6x. Chain rule, dy over dx equals 5u to the power 4 times 6x equals 5, 3x squared plus 1, to the power 4 times 6x equals 30x, 3x squared plus 1, to the power 4. Example 2, differentiate y equals sin of x squared. Let u equal x squared, y equals sin u, dy over du equals cosine u, du over dx equals 2x. Chain rule, dy over dx equals cos u times 2x equals 2x cos x squared. Today we covered 3 advanced differentiation rules. The product rule, d over dx of uv equals u times dv over dx plus v times du over dx. The quotient rule, d over dx of u over v equals v du over dx minus u dv over dx over v squared. The chain rule, if y equals f u and u equals g x, then dy over dx equals dy over du times du over dx. Multiply the derivative of the outer function by the derivative of the inner function. For your practice exercise, differentiate these functions. First, y equals x cubed times sin x, product rule. Second, y equals x squared minus 1 divided by x plus 3, quotient rule. Third, y equals the square root of 5x minus 2, write as 5x minus 2 to the power 1/2 and use the chain rule.